Oh, snap dizzle. Hold on a second. I love opening the window to get some fresh air, but then it looked like some birds were gonna come in. I was like, not today, please. Okay, let's go ahead and get started. Let me go ahead. Do some. Let's do some leak code. Let's do some random ones and see how that goes. As always, we'll time ourselves and we'll go fast too. Okay. So all topics. Let's see. Let's do so not pandas. Let's do some algorithms. And then we're gonna sort by difficulty. It seems like all of these. Okay. Download frequency. Okay. I was gonna pick that one. Let's see what we get. Let's do a baseball game. No, let's not do it by easy. Let's do it by acceptance rate. I want to see by the highest ones. These are locked, so these look like they're Leak Code Premium, which I don't have yet, but I'm thinking about getting one day. But sometimes eating Leak Code reverse K arrays. Because sometimes Neat-code would have the problems. Reverse K subarrays. I don't know. I don't think that's the same one. But that's okay. Let's pick this one. And it's supposedly easy, but we're gonna find out if I prep for it. Let's see what I get. Okay. So you're giving an integer array nums and integer k. You can perform the following operation any number of times. So you can select index I and you can replace that certain value with the previous one. So if you can return the minimum number of operations required to make the sum of the array divisible by k. Okay. Okay, let's talk about our inputs and our outputs. So we're going to receive a list of integers in an integer k. We need to return min number of operations to make the sum divisible by k. So we have to make sure that we have to make the amount of operations. So we need to return the min number of operations to make a good sum. Make a good sum. So if we have 2, 3, 5, we have, what would be good? Let's work off of our current example first. 3, 9, 7. 9 and 7, and we have an integer of 5. Okay, so I started this around 5:07, so we're 2 minutes in. So if it's easy, I want to do less than 10 minutes, so we're gonna go through it really fast. Okay, so they're saying 4, so we can perform 4 operations on the nums of 1 at 9, because the reason why you need to perform 4 operations, because you get 3, 5, 7. 3 plus 7 is 10, plus 5 is 15. Perform 4 operations, because you keep everything else. Number required to make the sum. Okay, I just want to so my head, I'm thinking dynamic programming right off the bat. The reason why I'm thinking dynamic programming is because I envision a decision tree. And one thing I want to consider is can we use the same number twice? And it looks like we won't be able to. It looks like okay, so if your total sum of it can be divisible by 4 cleanly and return back any kind of number cleanly, no floats, no point, anything, you don't need any operations. So the reason why I'm thinking of dynamic programming is, okay, so we have, but the reason I'm thinking dynamic programming, so we can either take a decision tree, we can either take 3 and a 9 and a 7. And let's see what that total 3 plus, this is 19. Okay, 19. Okay, so it's 19. It's 19. Total is 19. And you can see we perform only 4 operations. So it's, to me, it's, because technically you could go, okay, so we're at 19. And 19 divided by 5 is not a clean number. But I wonder why they decided to go down to 15 instead of go up to 20. Because even if we go up to 20, because you could say 7's an 8, or you could say 3 is a 4. That can give us to 20. 20 divided by 5 is 4. So minimum operation should only be 1. But why do we go down instead of go up? Okay, so and you can only replace the current value with a number minus 1 every time. Because you can't increment forward. Okay, so you can't increment forward. And if you go down to 2, 3, so you keep everything else. And my decision tree is thinking, okay, so decision tree is saying that, okay, so if we go with our first one, it's 19. Okay, we don't like that. Let's go with our second one, another one. And we have a 9, 7. As you can see right here, oops. 297, as you can see right here, 297, 11, this is 18, this gotta be 17, 10, 7, okay. As you can see right here, we want to keep 3 as is. We want to keep 3 as is. Number 3 is equal to 3, and 2 is equal to 2, but you can keep it to 0. Okay, otherwise you keep incrementing down all the way until 0, and then you know that the sum is 0, which is divisible by 6. Okay. Otherwise, we're going to keep 3 as is, but because you can see 3, 2, or 1. So my decision tree is going to start with all 3, 9, 7. And it's going to tell me, hey, we're going to start with 3. We're going to start off with 3. We're going to start off with 3. We're going to see, does 2 work for me? Does 1 work for me? Any of them clean divisible number? No, they're not. So we're going to go off to our second number. So we're going to go off to our second number. We're going to keep 3. We're going to say that we already tested 9. So we're going to increment down by 1. 3, 7. 3, 7, 7. So there's got to be 18, there's got to be 17, and so on. 3, 6, 7, and 3, 3, 5, 7. So it seems like for every number, we're always going to decrement by 17, 16. For every number, we have to decrement by 1. And we're going to try to see, hey, we're going to decrement by 1, and we're going to say, hey, can we make a, right here, divided by 3, this is, so you have to go down 4 times. For every number minus 1, increment a count. And we're going to check to see if the total is divisible by k. If that is equal to a full integer number, is equal to 0. Well, we wouldn't say equal to 0, because 15 divided by 5 is 3. But if we say that I get the total divided by k, you could say 17 divided by 5 is true. But how do I say, hey, if you're equal to a whole number, mod? I'm going to say mod. How many times? Because 15 is divisible by 5. Because 15 can be mod into 5 3 times. and that gives me a remainder of 0. That's what I'm thinking right now on top of my head. So right off the bat, we're just spinning. So we're gonna check to see if the total is mod by this and if there are any remainders left over. And then we're gonna return the count that we see. Okay. Anybody have any thoughts? With doing any decision tree, any dynamic programming, typically it will be, now you could be wrong. I could be wrong. But with dynamic programming, typically there's always recursive, there's recursion is typically involved. And I have to think about base case and edge case. Base case. And also base case. So a base case, and then we have to have a recursive case where they keep calling itself recursive case. A base case, what's a good base case? What I would say, base case, if the total sum of the list is mod by the k already, then we just return 0. To me, that seems like a good case to go ahead and end it, telling the recursive case, don't go and do anything. Otherwise, recursive case, let's go ahead and iterate through each number, check to decrement it down, and we're going to increment the count of min changes that occur, and we're going to return the min changes. So if sum of nums, the list is called nums, if sum of nums is mod by k is equal to 0. Sorry, I was thinking mod looks so weird for a second, but that is how you say mod. If sum of the nums mod by k is equal to 0, we're going to return 0, because if we know all of the sum of this is already divisible by 4, we're just going to return our output of 0. And it seems like there will be negative numbers involved. No, there won't be, actually. There won't be any negative numbers. How do I want to go ahead and handle negative numbers? Well, if the sum of the nums is ever less than 0, we're just going to return, I'm going to go, if the sum of the nums is ever less than or equal, let's go less than 0, because you can still be equal to 0, is less than 0. One way that I think about it, that's a safe way to go, and one way that is safe to go ahead and guardrail it is to say float infinity, that we know that, hey, we can't even make any changes to this. So, but I don't foresee that, but I'm confident in this. So one thing I want to go ahead and take into consideration too is that, hi, long time no see. How have you been, Ghost Magic? Okay, so one thing I want to do is also, I want to make this into a helper function. So we're going to take the nums and we're going to take k. So we're going to take nums and we're going to take k. So what's it called? Min operation. Min operation is going to take the nums and it's going to take the k. So I want here to return a min changes. In min changes, I need to initialize you to float infinity is what I'm going to initialize it to. The reason why I'm going to do float infinity is because if we're thinking about minimum, I know that I always want to get the smallest amount of the smallest amount of steps. So I feel comfortable setting it to a very high number. Please let me know what your thoughts are too as well. but that's what I do feel comfortable with. And now we're gonna go into every integers for num and nums. If the min operations, we're gonna say that num minus 1 k, if num, what this is supposed to return back to me, hold on a second, let me turn on the fan quick. Okay, so what min operation I anticipated to return back to me in integer, and it's gonna return back to me a float of infinity, and we're always gonna have to pass in. We're gonna say this is actually new total min operations here. If new total can be mod by k and is equal to 0, we're gonna say the min changes plus equal 1. And if min changes is ever less than our new total, if min changes, we're gonna say changes. If min changes, then we're gonna say if our new total mod by k otherwise, yeah, I feel comfortable to say that if our new total is equal to that, the min changes are equal to whatever the new total is. That's what I would feel comfortable. It's gonna return back here. I don't anticipate it to work fully because typically with, especially in very big numbers. Okay, you didn't like any of it. Okay, if the sum of nums, I'm saying if the sum of the whole entire list, you're gonna mod. Is this not how I do mod? It's been a while since I've done mod. I swear you're mod. Mod k modulo Python. I swear you're a the percentage. Mod, not modulo. Sorry, my bad. See, it was a percentage. And it should return back to me in integer. So, in object is not iterable. But why wouldn't it be iterable? Because when you take a sum of a list, it becomes one integer. And then you can mod that by the other integer, which k will always be an integer. Print sum of nums. Did I indent too much? Oh, okay. I didn't indent enough here. As you can see, def. Okay. Def. Okay. Let's try that now. I think indentation matters. Definitely pay attention to that. Okay, so we've been at it for self.min operations. Yes. That is my fault. Self.min operation. I was like, someone I'm sure it worked. Did you mean the sum? Did you mean self dot? Okay, yes. That's my fault. Self dot. Hi Eddie, congrats on making it third place. Or sorry, not third place. Third round. The final round. That's what I meant to say. Sorry. I was thinking about something else. Day 2, wait, 3 were given. Return min of the south. Nums k. But self. I want to say it like this. Okay. I am going to tell you to do that. He should be that. Okay, you didn't like that. You're gonna return. Okay, I want to turn self, nums, and k. How about that? There was here. I needed I honestly don't think I need a self here, because I am defining the function here, but 3 were given. Self.min operation, 3 were given. Before takes 3 positional self noms k. I am going to need a little help with that because I didn't think I would struggle with the self. How's you guys Thursdays going? Oh my gosh, it's hot out here. Okay. I didn't like the self because self is really right here. I know, I think that's what it is. I think, like, maybe I'm overthinking it. What is the... Yeah, I've been wanting to do, I want to do this a little bit more in a time matter, too. So I have, like, less than 2 minutes. So I'm going to try to see what I did wrong because this was working just fine. And I strongly believe that there's nothing wrong with my sum of nums right here. I don't really think there's anything wrong with that. Okay. Let me know if you guys have any other ideas as well. I like felt so strongly that it was gonna be dynamic programming. Like I swear I thought it's gonna be dynamic programming. Going once, going twice, going 3 times. I gotta look it up because you're just gonna calculate the total sum, find the leftover. When you divide total by k, whatever leftover remainder is how much you need to move. Stop. That was so easy. I think it was definitely over engineering that way too much. I'm so sad. Okay, let me add this in. Because what do you mean? Okay, so all it's saying is that, okay, before I got into dynamic programming, I was thinking about their numbers here, and you can see how they perform 4 operations. So I went based off of their example, and I thought they went through each individual value, and they decremented by 1 until they can get to a total sum. But it seems like you can say total is equal to the sum of the nums. So you got the full total, and you're going to say that if total, you're going to say, what would you call it? Remainder is equal to the total mod k, and anything left over will capture the remainder. So if 5 goes into 16, how many 16 mod by 5? Since 5 can go into 15 3 times, 5 times 3 is 15. You have a remainder of 1, and that's what you need to go ahead and just return. Oh, it was that easy. Oh my gosh, I am so depressed. Okay, We need one more. I need to redeem myself. I didn't think it would be that easy. Typically, when you do find me the min change of this or find me the max of that, when I've read some of these problems, I think about dynamic programming. That's when I've seen it. That's so sad. I have heard of greatest common divisor, but it's been a minute, but there is a certain logic with it, so I will have to come back to that. Okay, so since it's easy, like we said before, it lasts 10 minutes. So right now it's 5:30. Let's start. Let's end it at 5:40. And feel free to please chime in and share your thoughts and your code and how you would go ahead and solve this too. I would love to know how you guys go ahead and come to your conclusion. I love reading other people's thoughts because when you think about algorithms and stuff like that, I've come to the conclusion that there's no one direct way to always to solve algorithms, and that's the beauty of it. Right, Ghost Magic. That would be nice. Oh, there's a heat wave right now out here in California. Where are you guys from? Ghost Magic, where are you from? Hopefully it's not too hot for you out there, Eddie. It's hot. So that only means summer's coming up, which is good because LA was stuck in like a rainy season for a little bit, and it was bad. Like Waymos got stuck, cars got stuck, and I was like, LA is not built for rain, so I'm not trying to get my car stuck out there. So yeah. Okay, 10 minutes starts now, 5:32. Okay, so let's go ahead and read the prompt. So you're given a string S. The score of a string, ASCII's, is defined as the sum of the absolute difference between the ASCII values of adjacent characters. So you're going to return the score of S. Oh, I feel like I should have this in my back pocket. I feel like, okay, so we're going to receive a string of lower. Ooh, I can't for sure say it's lowercase. Okay, yes, I can now. Lowercase chars, and you're going to return total amount. Ooh. Is defined as the sum of the absolute difference between the ASCII values of the adjacent characters. So HE, you take it and you divide each other, plus the next 2, return the total, you return an integer. A sum from dividing 2 numbers together. Okay. Okay. What I'm thinking of, base up, let's do HEL. Let's do 3 numbers to start off. Typically when I do edge cases, not edge cases. Typically when I start out with any examples, I always make sure to start out small so I can see it at a smaller scale first before going off and starting anything bigger. So maybe even better if we start at H. So for sure H is the ASCII value of H is 104. So we know that it's 104. And because we know that there's no adjacent characters to it, this would be a total of 104. So if there's no adjacent number to it, you could say 104 is 1 minus 0. Otherwise, you could say HE, which is 104 minus 101. So if you have 2 numbers, you take the number right next to it. And something that makes me think about this is like, in the case of evens and odd, that's what I'm thinking. If you're an odd and an even, because if you're going to take an adjacent characters, I'm just trying to think about how I can take adjacent characters next to each other. I can definitely do odds and evens. I can do 2 pointers, IJ. I think I'm going to do an IJ, not in a nested for loop. So we're going to say I is equal, okay, so we initialize I to start at index 0. We're going to say, how are we going to say this? We're going to say J is equal to 0. I'm gonna initialize j to 0 right now. Just spitballing. J to 0. If I is equal to j, if they are equal in the same spot, if their position of the index is at the same spot, we're going to go ahead and say, hey j, move up 1. Then we're going to take the total of that. So this one is saying 3 plus 7. So then take the total from the two numbers. So we're going to make them subtract each other, deduct each other. We're going to make them deduct each other. And we're going to grab a total. And then we're going to grab so then we're going to update the total, and move on. Then we're going to move I pointer in front of j. And that's what we're going to keep doing. I is equal to 0, j is equal to 0, while j is still less than length of s. We're going to say that if I is equal to j at the same index position, we're going to say j plus equal 1. But else, we're going to say, hey, take total is right here. Total is equal to 0. Did we say it was... I'm gonna say, I don't know if there will be negative numbers, but I feel like you could possibly have a smaller number in front and a bigger number afterwards, resulting in a smaller number. So best way to go ahead and say is negative infinity. So we're going to initialize it to a negative number, the biggest negative number right now. And if it's bigger than the total, we're always going to update the total later on. Because it didn't feel right to say, hey, total, you're equal to 0 right away. So, because we could possibly reach negative numbers, But otherwise, we're going to say current total is equal to s of I minus s of j. Okay. So we're always going to take the first value, and I will always come before j. I and j. So I will always come before j. So that's why we're going to do s of I minus s of j. But we need to turn it into the ASCII numbers. To do in the ASCII number, is it ORD? ORD Python. Nope. How to turn numbers into ASCII Python. Char. Tell me char. Yes. Okay. CHR. We should just be able to say CHR. Built-in function. And then we're going to say total plus equal the current total. So this one will be saying, hey, H right now is 104, and this one's going to be saying E is 101. So it's going to say 3. So this is going to add on to 3. And then total. And then we have to move I is equal to J plus 1. Because it's always going to be in front of J. It's never at J's position. It's going to be in front of J. Because say, for instance, if we have example AGHEL, then I, first round, I is going to start here, J is going to start at the E. And then now second round, so I don't want it to start here because that would be double counting because we already took care of the E. So we're going to say, hey, move on past J and start it here at the third. So, and then that's what we're going to do. And then we're going to return the total that we received back. String character, you're right. No. Okay, you're right. Okay, some reason I thought it was gonna be really easy. Okay, char. Okay, how to turn letters. That's my fault for saying numbers. So then it's ORD. ORD. You know, I need to Inky that. I need to Inky these numbers because this would be so helpful into Python. This will be really helpful for technical interviews and be like, hey, I really know that there's built-in method, this built-in method in my toolbox, and I wonder if I broke it. Oh, I broke it somewhere. Okay, let's figure out where we broke it. Oh, thank you for following along. Okay, I have 2 minutes. Oh, okay, I have 2 minutes. Okay, let me think. Okay, I is equal to 0, so we're saying, hey, we're starting both at zeros, and then you know why it probably broke? I'm thinking, okay, so I both start them at 0, and but the thing is that I'm saying that, hey, if you guys are both equal at the same index, J move. So right now 0 0, so they're both at the same index. They're both at the same index. J needs to move over by 1, and then now we go back into the loop again, and we're saying if I equals J, if they are the same index, which they're not anymore. So let's go ahead and take the current total. Let's turn them, morph these letters into their ASCII values by the ORD, and then we're going to take the current total, because we should be at I and J, so our pointers have both moved to different letters. They should have picked up new numbers. Let me just print out my I and J positions, see where they are, and I was supposed to finish already. Okay, I want to see where my I and J are. Please let me know what your thoughts are as well. Like, this algorithm programming is it never moved. It never moved. Okay, it never moved. Yes, this programming situation is supposed to be very collaborative, so feel free to let me know what your thoughts are, and feel free to have that conversation with me as well. And then J plus equal 1. I never told J to move, because we're gonna move I first, and then we're gonna move J after. But I thought it would have been captured here. Okay, so that helped it. Oh. No, it didn't. Okay. Give me 3 minutes to debug it by 5:45. If not, we're just gonna call it. So feel free to let me know what your thoughts are as well, because I was thinking of using the 2 pointers, I and J, right next to each other. So if I equals J, so I is equal in front of J. I don't think I just want to test, but I equals J doesn't make sense, because your return total float negative infinity. How come it returns null? So our current total isn't adding anything. Print current total. It seems like our current total isn't adding anything. It should though, because I need a print ORD next. Okay, current total does upgrade, which we do see. We have a 3 and a 7. We have a 3 plus 7, and we just have a 7 forever. Why did you get stuck? 3 plus 7. 3. So we are 3 right here, our 7 right here. Okay, so we do reach 3, 7. Okay, let me think about it. Yep. So HE, so E 3, 11, LL. Okay, so EL is 101. This is the 101 to 108. So you want to count that. So I actually want I to start out at J then. Because HE, and then I starts here. So I'm going to move I to J. Negative 7. 101. Oh, but you're taking the map to absolute no matter what. Okay. I'm going to do the absolute function right here. And that absolute function will go ahead and convert. Oh, sorry, let me finish my thought. So you do the absolute right here, and that will always convert that negative number to a positive number. As you can see, 7, 101 minus 108. Technically, that should be negative 7. I should have paid attention to what these bars meant. These bars meant like absolute, and absolute is you want it to be always be the opposite number or positive number. And yes, the reason why I is always equal to J. Like, are you talking about line 33? Is that what you're referring to? Well, because the reason why I want I to equal to J, you know, you got a good point. All I need to do is just say, hey, I need you to move by 1. The reason why I want it to be J is because J will always be 1 in front of it. That's why I wanted it to be. Let me 373. Okay. Something's working, but then something didn't go through. Oh. What? What? Okay, you know what? No, wait. Is it because, okay, so I'm getting the right number, 3703, 3703. And it's returning total. It should return total because total plus equals the current total. Is it because I'm trying to add by float and it never adds by float? But if I update it to 0, does that give it more of a credible number? It does. Why adding to float negative infinity Python returns nothing? Returns null. To be more specific. Note that this is the very nature of binary that is not a bug, and it's not a bug. Some kind of... nope, that's not the... that's not... Well, when adding to float negative infinity, why does it return? Though I can ask ChatGPT right now, I want to try to still harness my good questioning and also trying to still use like Google for a little bit too. Python. I guess if you think about it, float negative infinity and infinity, because the way I know is that negative infinity and infinity in Python is always expressed by saying float. And when you do that, you get a floating number. Is that why? Nonetheless, let's talk about our... Right, so Ghost Magic, what you're saying is... So what you're saying, it's... If you have two indexes, I and j, which I do have here, j is always I plus 1, yes. So it's always 1 ahead of wherever I is going to be. And if you're going to remove it from the beginning, are you saying that you remove j? Then it's good to remove it at the beginning because managing one index. Because technically here, all we're managing is one index at a time. Is that what you're... State reduction, even in... Because, sorry, when you say state reduction, my mind was thinking about React. But then, so when you say state reduction, that's also an algorithm thing? State reduction. Okay, now you say state reduction Python, or should that be like overall programming? I don't really think it's the function. Reduce function. It does. I did not know that. State reduction. Oh, you learned something new. That was prior to when state wasn't actually introduced, correct? So, you had duplicated pages. Please tell me more. Yeah, I can definitely like look it up too. But oh my goodness, just learned something new. That's really good to know. As always, friends, we always gotta talk about time and space complexity as well. So time-wise, okay, well, time-wise, when we took a look at this operation, we're doing I and J, and we're going to iterate through the string at least just once, and we're only keeping track of a running total. Therefore, I'm going to say time is only be O of n, because we're only going iterating through the operation, or iterating through the string once. We're not doing any additional storage, so we're just keeping that running total. I feel confident to say space is all constant, or constant, yes, no, constant, linear, yes, linear, constant. You had variable x in memory and y in what page, and if it's duplicated, it introduces zero. Oh my goodness, then how was it resolved back then? How would you... I wonder how you guys went about to go ahead and reduce that then. Because if it introduced errors, how were you able to debug and locate? I'm just so curious because, yeah, I wonder how that was done back then. How do you read states in JS? We put them in an object. Use reducer. Oh, I didn't do it as fast though. No idea. Just kidding. No, oh my goodness. So you're iterating through each one of the strings. You're gonna say, you're always, my concern, I've never had any good luck with the one I plus one. I've never had, yeah, let me see. I've never had any luck doing I plus one, because the reason why I don't do I plus one, well, I guess if you're always just going to the last one, so I guess they did do, because I'm always falling off the length of the argument that's passed in, and so at least they can do it like they guardrail themselves by saying, hey, strictly just the last, go all the way in just until the last integer. Yes, this one just, yes, an index of I only. And they kept a running total of A is equal to 0. Oh, yes, yes. Oh, that's so interesting. Okay, now I understand what you're trying to say. Okay, so when you do any, I don't know if I'm saying that right. Index pointers. Yes, sorry, I'm sorry, I was referring to A as a running total. But yes, the index of I. Yes. So that's so interesting because, yeah, when, if I can say it right, like index pointers are like multiple state, and they can keep track of different areas in your argument, but you don't want to use IJK. Typically what I would use is IJK. So, but, or I mean, I don't try to stray that far. I try to stray only at I and J, unless you're talking about, the only time I've done IJK for brute force for 3, when you add 3 sums together. I think that's when I did it. Oh, I see. Yes. Yeah, I'm just trying to think about like a lot of variables and what they're gonna keep track of. You're right. You are right, Ghost Magic. Thank you for sharing. I learned a lot. So they only have one index, and they're just gonna keep track of the 2 values. I see. Okay, talking about React, I love this one. So we're gonna figure out what I learned from last time. So this is called Big Front End, and it's all about React. So it's gonna, what you're gonna do is you're gonna go ahead and say, hey, what does this code snippet print out on your console.log? And so I've been wanting to get better with understanding like how certain items or how components and hooks are run through React, like which one will get printed out first, what will get re-rendered. And I've been finding this big front end dev been very super helpful about that. So such as say for this example, I felt like I went through it last week, but I can't remember it on top of my head, but let's walk through it. So as you can see, it's just the usual. So we're gonna just import React. We're gonna import some hooks. We're gonna go ahead and import the create root. So that will go ahead and create that instance. If I stated that correctly, feel free to let me know too. I really want to get better at stating my terminology correctly too. So you're gonna go ahead and import that create root. So what that will do is you're gonna just be able to render your application. So you have a create context, and then you have a function B that has the children, that takes in the children. Sorry, I stated that wrong. And you're going to have a count, and you're going to use context. So I'm not too well versed with use context, but I'm willing to go ahead and learn more about it. I feel like I hope it's okay. Use context React. We're just going to read a little bit about it, try to understand what it does. That lets you read and subscribe to context from so it just allows you to read and subscribe. Okay, I wasn't sure if it was going to do any like, because for which page was I? Yes, this one, because I know that with use effect it does some side fetching. So it will do some side effects work where it will leave that specific component and it will go and do some work outside and come back into the component. So I didn't know if use context was like that. So it seems that use context allow you just to be able to read it. And so, and after that, you should be able to read that. And then then this will be printed to the console of a B, and you can return its children. Then we have not a function but a variable A that takes in children. This function declaration, this is higher order function, or sorry, not higher order, is the one where you take a function and you assign it to a variable. Please feel free to let me know what your thoughts are. Hopefully no one gets lost, so let me know what you are. We can definitely do some work to go ahead and brush up on it. But we're going to have a state, and we're going to default it to 0. Then we're going to print A, and now we're going to do a use effect. And we're going to say, hey, do this set state will increment by 1. You're going to return my context provider. My context dot provider, which would be implemented there, of that current state. And you can say the function is C, which is prints out C. It doesn't return anything. Same for D. Okay, so now we have the actual app. So as you can see right here, root.render is going to render our app application. So app is going to run, and we're going to print out, what's going to print out first will be app. I feel really strongly about the fact that we're going to console.log, then we're going to say, hey, let's return what our function A is telling us. So now it's going to run into, the function, into A. And what we're going to say here is we're going to set state to 0. We're going to console.log A. I think I always forget like how to do this. I think you comma and then you say the next one, or I think you say nothing. We're gonna go with nothing right now. So A, console.log A, and now you're gonna go, there's a use effect. And use effect typically takes a couple minutes, or not a couple minutes. It depends on the situation, but we're not gonna render it right now. And now you're gonna render my contact provider of the state and its children. And what my context provider is going to relate or refers to is create context right here. So it's going to return back a state of 0. And also, you can see the use state is 0, but I feel confident it should return back 0. And then after that, we go into B. B is going to take in its children of C. So it's going to take its children. It's going to take in its children, and you can see that the children inside of B is C, but it wants us to go ahead and do a use context of my context. So another 0, and then we're going to print out B, and then it's going to say, hey, let's render my children, which is C. So we're going to render C, and now we're going to go to D, which is just D by itself. And now we're going to go back and close up A. And then here, we're going to go back and close up A, and I'm going to say the use effect will be updated. And it's going to increment state by 1. That means that we need to do A. And that means we need to do my context provider of 0. Let me know what your thoughts are. I feel like this is really ugly, but this is what I think. I think that's a lot. Okay. Use double quotes. Okay. He likes only double quotes. I know. Let me know what your thoughts are if you feel the same way to this as well. Okay, I updated double quotes. Okay. It doesn't like that. Okay. It doesn't like that. Okay. Let me know what anybody's thoughts are. Let me know. Otherwise, I'm gonna take a look because I have not. Oh, I believe in you, Ghost Magic. Watch, it's only gonna be like 4 lines. Let's see what they state. Okay. The trick is knowing how. Stop. Okay, so answers. There was never any state that it was needed to be updated. So it's only talking about. When you think about it, it's only talking about the console.log. So we only care. Do I have it printed? Nope, I don't have it printed. So we only care about the console.log. I don't know why I was trying to bring state into it. Why didn't they add one thing? Okay, yes, they did add app. I was like, wait, why didn't they add an app? Because you should add an app. Okay, let's do this again. Let's just pay attention to the console.log only. Okay. By the way, friends, a shorty is looking for a job, so let me know if anybody's hiring. Feel free to let me know. So I am looking for anything. I am like very full stack. but I lean a lot more towards like the front end. I am not too big of a database person, so, but willing to do it, but yeah. Okay, so we're gonna do console.log. And so root.render app. So we're gonna go to app, we're gonna console.log app. And now you're gonna run into another console.log. Into A. So we don't care about state. Nothing to be worried about state. I was like looking way too much into this. So, and now we're gonna console.log B. And now it's gonna return its children, which is C. So C will be render as well. And now B and C are done. We're gonna do back D. And now we close out A. Oh, that's not right. Because we're gonna go to app, we're gonna go, A is gonna run. So console.log A. Now we're gonna go into B console.logs. And then we're gonna console.log C because it's children. So B closes out. We're gonna say we're gonna console.log D. Okay, cause okay, so I get it now. Okay, so now we're gonna close out A. So use effect is gonna say state plus 1. So state is gonna go ahead and re-render. So when state re-renders, cause when React re-renders when state changes, prop changes, state changes, prop. There's a third element. Oh, I forgot in my Inky. But when state changes and prop changes, the whole app goes ahead and gets re-rendered. So we know that it's gonna go ahead and run all over again. Hence why ABCD afterwards. No, it didn't even work. Okay, wait. Okay, ABCD and only AB because of the state. Oh, I knew there had to be something with the state. So app, and we have A, B, and then we have a C, D, and yeah, with state updated, we know for sure A is gonna get updated again. But why is just B? Oh, because you have a my context provider. But if you trigger B, you should trigger C because it takes in its. It doesn't matter because it's only the state updated. Oh, that's tricky. Yeah, okay. It doesn't matter because my context provider triggers here. That's why you console.log B. But now that the second time around when the state updated, children is not going to take anything in. That was a doozy. How do we feel about it, chat? Okay, so I have a use effect too. Let's figure out this bad boy. Give me a couple minutes. Just gonna drink some water. I'll be right back. my friends. Okay, let's go ahead. I hope you guys got a little break yourself to in some water. Okay, let's go ahead and check it out. Reading from top to bottom, as always. Hello, thank you for coming along. Thank you for following. Okay, so as we did this, we are going to read from top to bottom. So we're going to import some hooks. We're going to import our create root. And so here's our function app. It's going to have a state. And it's going to be default to true. And we have a ternary, which is called conditional rendering in React. Conditional rendering. It's going to say if this is true and this. So if this is true and this, then we have a child component. It's going to take an unmount. Unmount, I don't think I've ever seen that before. I'm familiar with children, but I've never, unless unmount is just a prop. And what we're going to do is going to render app. So we're going to just look at the app, the functions. So this one is truthy, and this is truthy. So we hit into child, and then there's no console.log that needs to be reported here. So we're going to go into the console.log. Const is mounted, and use is mounted. Use effect will come later. So this hits this function right here. Use is unmounted. Use ref is false, so it flips it to false. And this one right here is saying that if it's equal to true, then you're going to flip it to false. And you're going to return whatever the current condition, which is false. So now this one is saying, hey, console.log, what is mounted? This one should be false. I don't think I need a string. So your promise resolve is going to be true. Then you're going to console.log. This is what I think is going to happen. And that, no, it didn't. Maybe it's because I needed the double quotes. Nope. So anybody want to go ahead and take a stab at it? Let me know in 5, 4, 3, 2, 1. Just kidding. But anybody else want to challenge my answer? Feel free to let me know. We can all definitely learn collectively together how to solve this. So yeah. I thought I figured it out. Hello, thank you for following. Here today we're just doing some React examples, and we're doing it using big front end. I really like them, so definitely check them out. I am getting myself more familiarized with React hooks, what's going to be printed out, what's going to be more of a delayed, and what will happen. I thought it was going to print out false true, but oh, it's false. Okay, and also I didn't need the double quotes. So in the first console.log, the value for is mounted is false. Yes, it was false. So changing a use ref value doesn't force a re-render as use state does. As I mentioned earlier, use state, the hook goes ahead and re-renders that specific function that it's being called into. And the use effect from the child runs with the values from the first mount. So the use effect runs from the value from the first mount, although it did get updated. So yeah, because if you know anything about the React life cycles, there is this I'm not too, maybe it's easier to show you. Let me show React life cycle picture. React life cycle picture. Maybe this will help. I think this kind of helps because, or let me make it a little bit bigger. So with React, I don't think they do the component did mount and all that stuff anymore. But the philosophy of it still stays the same, where it will go ahead and mount and it will update, and if any you have any state that needs to be updated, it will go ahead and update, and then it will unmount. So this kind of forces me to learn the React lifecycle and understanding what will go ahead and get rendered. Yeah, React lifecycle. I wonder what's a good. Yeah, React Dev itself is very credible. So it mounts, it will go ahead and update and unmounts. So I feel like learning all of this will help you learn and solidify more of your React lifecycle methods. Where did it go? So let's go ahead and go back to what we learned. Even with the cleanup function, the use effect running before the. Yeah, let me know. Does this help anybody? Does anybody need any further clarification? I think I will definitely have to let this stuff sink in a little bit more. Initially, the value of ref.current is false, which is capture, and also get familiarized with more hooks. As you can see, use ref doesn't cause re-render that use state does, so that's something new to learn. So after the initial render, the value of ref.current changes to true, but it's not reflected in the use effect. All really good information to learn. So, okay, as we stated before, it's going to go ahead and render our app. So it's going to render our app, and it's going to run. So state right now is true. State right now is true. So we're going to say that this is true and this is true, which gets us into our child. And then we go into here, it's going to hit our function. So right now, use ref is stating false, and our use effect is running later. So our use ref, this is where I think the false is coming from, is coming here first, and now we're gonna say that use effect console.log, because this because we went from this child component right here before we jumped into here. So now we can run through all of this before we finish the rest, because use effect is not intentionally, I wouldn't say intentionally, but there is a delay on it a little bit. So we go back to our use effect here. This one right here is still false before it can be turned to true, and then it returns back to false. I want to be better also to at explaining it verbally. I don't know if that makes sense. Maybe this is something that I will have to come back to in a couple of days and be like, okay, I remember seeing this. Let me try to active recall and see if I can recollect why it was the case. So, but let's do one more. Let's do a memo. I don't know if I've done a memo yet, but okay. So, anybody familiarized with memos? Let me know what your thoughts are on memos and if you're familiarized with what memo does. Don't get all shy in the chat. Let's go. You can definitely write whatever comes to your heart's content. So from what I remember, memo is a hook. So memo is a React hook, and it will go ahead and cache and store. So basically, when you say cache, you're gonna store a result of a. Typically, I've seen memos with like API calls, because it's expensive to go ahead, and it's usually used for expensive operations. I've seen it stored with API calls, and you go ahead and store that information into an object so that you can easily retrieve it faster and not as expensive as it was before. Faster because it will easily recall that before reaching out to the API call. And it's better to go ahead and reach out to your database instead of in your database. Well, I wouldn't say memo. in the cache area would stay in your database. Typically, it stays, it's away from your database, and it's like, yeah. I don't know how to describe. Well, essentially, it's not part of your database. It's something else separate that will keep. It's a key value object that will go ahead and store your expensive operations results. And next time when you need them, you will go ahead and just fetch out to them. So it's easier to go ahead and fetch it and retrieve it back. It's not going to cost you as much as it did initially. So. Ooh, I did say that a lot. Okay, but I promise I'll get better. So feel free to let me know what your thoughts are. I hope that makes sense with what Memo does. Because when I think about Memo, I think about memorize. Like it's gonna memorize all these information for me. That's one way I was memorizing all of this stuff. So, okay. So we have some testing here. Oh, fun stuff. But we have a function that's going to console log that b, and you're going to store that into the, you're going to store whatever this function returned back into the memo, and you're going to restore, call it under b. And then you have a helper function a, console.log a. You're going to also store that into a, okay. And then you have an app, you have state, you're going to click. So button's gonna go, it's gonna increment count. That's cool, but we want to pay attention to console.log. Before we were doing state, but we definitely don't want to go towards state. Okay, but now we're gonna run A. A is gonna run whatever is stored into the memo here. I feel comfortable, or double quotes, remember. So A, and then now it's gonna run into B, which is B right here. B. And that's it. I want to pay attention. Okay. Because you're going to go. My thing that's getting me paused right now. I was like, wait, it's way too easy. Because, okay, so A right here is going to take in its children. Children is B. And it's going to console log A. Then it's going to run into B. I think there would be two B's. Because you're going to run the B here. No, you're going to run its children. Children is going to be B. B is right here, and it's whatever B is here. I think it's just going to be AB. Let me know what your thoughts are. I almost thought it was going to be ABA because I almost thought it was going to be ABA. But I feel comfortable to go ahead and say it's A and then B. Any second last changes to the code? That's what I was thinking, because if A and B's memoized to here, A's memoized to here, then we don't need, because my only concern with memos, the way the memo works is that it will go ahead and re-render only if something of it has changed. So if the children changes, then we're gonna go ahead and have to recall back. We have to go ahead and do another, like the fetch or call out to that function to capture the new updated result so that we can memoize it. But I feel confident with AB, last call. So, yes. No, okay. Okay, so it is not the case. We did think that A was going to shoot first, then B was going to shoot first. So A was going to shoot first, and this come from the memo. And memo is going ahead and take in the function A. Inside of function A, it's going to take its children. Children's B, but we're in console.log A first. Then it's going to go ahead and run its children of B. B right here is going to console.log B. And we're going to store that into B. I almost want to say ABB. Because you're going to return its children, and then you're going to... I was going to say ABB because you're going to call its children A right here is saying, hey, we're gonna accept the children, but before we call our children, let's console dialog A first. So you think it's BA? I hope your name is pronounced Fitzy. I hope I pronounced your username correctly. But so you think it's BA? Is this what you're thinking? Dude, the only reason I'm kind of curious too. It could be BA. My thing that I think about it is it's gonna call A first. That's why this console dialog right here is telling me, this console dialog right here is telling me that A is gonna run first, then B. That's the only reason why. And A here comes before B. But do you want me to try it? I could definitely try it. I'm kind of curious too, because if it was right, okay. Nope. Okay, it's not BA. I feel like A and then B and then B again. Nope. Okay, any other guess? I understand it's a lot of guesses, but we. Oh, I see. What do you use now if you don't use React, by the way? A is gonna get printed out. It's gonna go into here and call this. Here, you're gonna store A, and you're also gonna store B. A, B. A, B. And then B. Okay, any last guesses? We're gonna take a peek at the... Oh, ABA, and then app renders. It shouldn't. React should render its parents first before its children. Normally re-render when its parents re-render. Oh, so the user event with the click me, when you click a button, everything re-renders. Oh, I see. Where do you use JavaScript and TypeScript? Do you use Vue or Angular? And do you use something else besides React? A memoized component will not always re-render when its parents re-render unless its props have changed. A component passes props children to its parent component that renders it. Belongs to the component where it is instantiated and passed to its parent, not the parent itself. Does not prevent it from returning a new... So much good information. So shout out to all of these people. So component app renders first. Did I not do the app render first? But yeah, it renders app. And it's going to go into app here. But we don't need a console dialog app. Yeah, I missed that because I was like, oh, you know what? It's a click me. But I should have paid attention. Because I did. So you did it here. You're going to click it. A button's going to click. But nowhere. But you know what I was thinking about is just no one here is mentioning a click me. But I guess in their testing here, you're gonna find the click me right here and you're gonna call it. So ABA runs, and then after that we're gonna run this by someone actually clicking it. Okay, so double quotes, B, and then someone's gonna click it. So you click the button, you're gonna set state, and state here is gonna increment by 1. So now we're gonna go through and see what needs to be updated. We're gonna console.log A for sure, and then we're gonna pay attention to its children. Since children it's gonna accept the component of B, it's always just gonna be a console.log of B. Since there's no update to it and it's been memoized, so it's been stored away in a result. Since there's no updates to it, we don't need to update it, and it doesn't need to be re-rendered. Oh, we learn something new all we learn something new every day. So when you click it, the state updates and we run it all back, and then we're going to go ahead and take a look. And A for sure, function A runs, but now we're going to pay attention to its children. I hope that helped a little bit. I mean, I still have to go back and probably look at this. I love to add all of these into my note card so that I can remember it for next time. Yes, the reason why, essentially, well, it's not really the click me that cause it to re-render. As you can see, when you click the button, you are going to update state. So anytime the state gets re-rendered, that's going to cause the whole React app to go ahead and get re-rendered. Anytime the state updates, anytime I have to look for the documentation, but anytime the state changes, the prop changes, React will go ahead and re-render. So it's not technically the click, so it's the state. Yes, yeah, you got it. Catching on so fast. Yeah. But I love this big front end.dev. I think I was just Googling one day, like, hey, give me some front end React work to work on. You just never know what kind of technicals you're going to embark on. So I wanted to be prepared and not prepared. Also, this has been very helpful to learn React. So. Oh, I saw pictures. Are you talking about like with vanilla JS? Also, there's the use of class components as well. So we've come. You guys have come a long way. But yeah, this is a great website as well. So if anybody wants to go ahead and do it, to TypeScript puzzle. I'm just getting curious, but maybe we'll have to do this next time. I think they only gave me like a certain limit because I don't have to. I think you have to buy premium, so I only get a very limited questions. Oh, was it? The state handling was a lot simpler with the old React. I see. Let's do one JavaScript promise order. What is the code snippet to the right output? How did I get my screen prettier before? Because I wish this one went right here. Not record, not submission, because I want to be able to see everything, you know? Oh, I love this. It did. I did not know that. Well, and Angular is still alive and well too. Do you use Angular a lot? Okay, so we have a console.log and we have a promise. And typically when I think about promise, I think about like use effect. I know it's going to take a while before we get that information because it's going to go off and do its thing and it'll come back later. And we're going to console.log, then there's another promise, console.log. And there's a set timeout and a set timeout. Oh, this is fun. Okay, so with JavaScript, it always runs from top to bottom, and it always runs from top to bottom. So we can start from the top, so we know it's going to print 1 for sure. Promise, hey, we'll come back to you shortly, but you stay still, go off and do your thing, we'll come back to you. So now we're going to do 4, same thing with this promise as well. Promise.then. When I started web development, I was doing a lot of .thens. But good thing we have a single weight now. It's a little bit prettier to read with a single weight than fetch that then. So, and we'll Yes. Well, I use try catch with my Async 08. Let me know what you guys use as well. So we have a console.log. So we know immediately these are gonna fire off. We have a set timeout, but we're gonna wait for 10 seconds. And we have a set timeout here that sparks off. Oh my goodness, you just do straight up raw HTML, TypeScript, and JavaScript? Oh my goodness, do you do the .query selector and all that stuff at work? And then console.log9. So with this set timeout, despite using the set timeout, I know that set timeout typically has a delay, but as you can see here, we're just saying, hey, shoot it right away. Set timeout with the 0 seconds. And now we're gonna do it. This one is how I feel we're gonna do, because I think it's set timeouts first before promises. So now we're gonna go back to our promises and we're gonna look promises.to. Oh, how do you like that? Oh, okay. 8 is your last one. I'm intrigued. Okay, we're gonna find out. Mad props to you for doing the .query selector. You must be a pro. Sorry. Okay, 2. Where's my... Okay, 2, and we're gonna resolve. We're gonna do the rest of the function here. And then 5. Okay, we're gonna find out. I'm gonna test me and then I'll test yours. Hopefully mine's right. No! Okay, because okay, let me test yours. I strongly really believe that set timeouts will or promise. Yes, it's the order of operation is going to be all the console dialogues, then the set timeouts, then the promises. But let's test yours. 1, 4, 7, 9, 2. Oops. 2, 5, 4, 6, 8. No worries. Here, let me copy this in. Oh. Copy. Copy. HTTPS. Okay, definitely try it out. Okay. Try it out. I really think, okay, oh no, okay. I was like, I lost it. Okay, so 1, 4, I'm gonna go all my console dialog that doesn't have any promises or any set timeouts. 1, 4, 7. 1, 4, 7, yep, 1, 4, 7. And I really believe it's gonna be my set timeouts first. That it's gonna beat my promises. 9 and 8. And then we got 2, and we got 3, and then 5, and 6. Okay. It's sure not the case. I almost feel like this resolve is gonna mean something. Like, hey, we're coming back to it later. I think we're gonna do a 2, a 5, a 6, and a 3. Let me know if you got it, Fitzy. Nine and an 8. 8 and 9. Okay. Did you get that right for you? Okay, 1, 4, 2, 5, 3, 6, 9, 8. No? Okay, let's take a look and figure it out. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Stop. It's sequential and a sync. 1, 2, 3, 4. Okay, so this one, so 1, 2, 3, 4 comes first. No worries, no worries. So what it was is 1, 2, 3, 4. Promise run construction function, because here resolve is not a sync. It's gonna run automatically. Oh, I should have right. Now we know. So because it's not a sync, that's true, because that's different from that then. This one is basically waiting. That's right. When I saw promise, I was thinking to myself, I'm like, automatically that's gonna be something that you have to wait for. I should have paid attention, but so now we know that it's 1, 2, 3, 4. All of this gets done automatically. This gets fulfilled, and now we have an async away. I'm curious. Okay, I really think my set timeout. So 7 is gonna print first, and then 9, and then 8, and then 5, 6. Because then we're gonna wait for the job queue from the async to come back. That's what I think. 7, and then. No. Okay, so promises come first before set timeout. 7, a 5, and a 6. 5 and a 6, and then the set timeout is in. Come back later. Oh. Yes. Oh, this resolve right here, it's not async. That's what they're saying. But we learned a lot. This is really fun. Let's do it again. So let's do it again sometime soon. I am gonna go and eat some dinner. So I hope you guys have a great rest of your night. Thank you for coming to hang out with me. I genuinely appreciate it. I'll be here again same time next week. So come and hang out. We'll have more fun. No wonder, Fitzy. Oh, okay. Set timeout. It goes into the event loop. And it's gonna wait for, because I thought promise was gonna wait for, it's gonna go into the event looper as well, because I thought promises were gonna go out and have the browser take care of it, and you'll come back into the task queue. Have a good one. We'll catch you guys next week. Thank you for coming to hang out as always.